This is one of the most interesting videos based on classification of rational numbers. We know that they are either terminating decimals or non-terminating recurring decimal numbers. We also know that they can be expressed as p divided by q, where q is not equal to 0. But just by looking at a fraction, can you tell if it's terminating or non-terminating recurring? Let's see. We look at 6 rational numbers in the p by q form. 5 by 2, 17 by 5, 8 by 15, 9 by 20, 17 by 6, 11 by 21. Without calculating the value of each in decimal form, can you directly tell the category each of them falls into? This category or this one? Let's make 3 rows and analyze it. Let this be the row of our numbers. Just for our understanding, let us calculate the decimal values of each in this row. And we write the form of each decimal in this row. By form, I mean either this or this. We will write t if it's terminating and ntr if it's non-terminating recurring. Let's try calculating the decimal values of each of the numbers first. 5 by 2 can be written as 2.5, so we can say that it is terminating. The digits after the decimal point end and do not go on forever. 17 by 5 equals 3.4, which is also terminating. 8 by 15 equals 0.53333 and so on. It does not terminate. The digit 3 is repeated indefinitely. So we can say that it's a non-terminating recurring decimal. 9 by 20 equals 0.45, which is terminating. So what we are doing here is calculating the decimal value of all the numbers and classifying it into terminating and non-terminating recurring decimals. Only 2 more numbers remain. 17 by 6 equals 2.83333 and so on. So correct, it gets classified as non-terminating recurring fraction. And 11 by 21 equals 0.523809, 523809 and so on. This part is repeated, so it's a non-terminating recurring fraction. Imagine trying to do all of this without a calculator. That's how your eyes would look, stunned. Don't worry, there's a quicker way. All we need to do is look at the denominator. Yes, even if we just look at the denominator, we can figure out if it's a terminating or non-terminating recurring. The denominator of the first number is 2 and the denominator of the second number is 5. We just need to keep a small thing in mind. We reduce the denominators to its prime factors. The denominator of the third number is 15. In terms of its prime factors, it can be written as 3 times 5. What about 20? It can be written as 2 squared multiplied by 5. 6 can be written as 2 times 3. And 21 can be written as 3 times 7. That's all we had to do. Reduce the denominators to its prime factors. Let's observe the denominators of the terminating decimals. The prime factors of the denominator are either 2 or 5 or both 2 and 5. Now let's look at the prime factors of the denominators of non-terminating recurring decimals. They have numbers other than 2 and 5. Yes, that's the trick. If the prime factors of the denominator are 2 or 5 or both, then the decimal is terminating. If the denominator contains any prime factor other than 2 or 5, then it's a non-terminating recurring decimal. These are the only 2 rules you need to remember. Have you noticed how simple it is to know if the decimal is terminating or non-terminating recurring? All we have to do is write the denominators in terms of its prime factors and apply these rules. Let's generalize these 2 rules. If the number is in the form p by q, then all we need to do is reduce q to its prime factors. For terminating decimals, q will be of the form 2 raised to m multiplied by 5 raised to n, where m and n are integers. It simply means that the prime factors will be either 2 or 5 or both. And how do we generalize q for non-terminating recurring decimals? It's simple. We write it as 2 raised to m multiplied by 5 raised to n multiplied by k, where k is a prime factor other than 2 or 5 and m and n are integers. It can be 3, it can be 7 or 11, whatever. If the denominator contains any prime factor other than 2 or 5, it will be a non-terminating recurring decimal.